Aloha class, today we're finishing up 6-6, which means we're dealing with some application problems. All right. Before we get on to 6-6 though, since the beginning of it can be pretty tough, we're going to practice a couple problems here before we get going. Okay. So here we go. We're going to look at, let's go ahead and do 36 and 44 to make sure we're okay. All right. So here we go. 36. 36 says G composite. Remember, that's the composite sign, f of -2. Now remember, when they give us a number to work with instead of a variable, we still want to write our first step of what this composite function represents. And we have G composite f of -2. That would mean it's G of f of -2. Okay, and then what we do is we're going to simplify. And when we simplify, right, we use our please excuse our dear Aunt Sally, which means we have to do parentheses first. Now, I do encourage some students to go over here to the side whenever you have to do some work like this. Okay, what's f of -2? Well, that means I'm going to use my f function, and wherever I see an x, I'm going to put in a -2. So since it's x squared, it's going to be -2 squared, which is 4. All right, and that's my answer. And so now what I'm going to do is come back here to my problem, and I'm going to substitute. Remember, you can always substitute when two expressions are equivalent to each other. So now we get G of 4. Now what does G of 4 mean? Well, that means I use that G function right there, and that would be equal to x minus 3, or in this case, 4 minus 3. So my answer would be G. All right, so that's what you have to do if you get a number instead of a variable to work with. Okay, now let's go ahead and look at 44. Okay, so here we go, 44. And in 44, it's f this time, composite G, and this time we have a variable. Okay, it's -a, and that's okay. It's still just the first step, though. What does a composite function mean? Well, that means it's f of G of -a. And same thing, like I said before, a lot of students buy into this side work, and it ends up being really helpful because you can stay really organized. And we're going to find out what G of -a is. G of -a means I'm going to use this guy this time, and I'm going to use that first. And wherever I see an x, I'm going to put in a -a. And I get this, and there's no simplification to do, and that's okay. But what I'm going to do is I'm going to take that, I'm going to put that in for the parentheses, and I get f of -a minus 3. Now here's where it gets a little bit tougher. Okay, because now I'm going to go ahead and I'm going to use my f function. And when I use my f function, it says x squared. So it means whatever I have in here, parentheses, I'm going to plug in for that x, and I have to square it. Okay, and I get that. And now remember, a lot of us are going to make the mistake here of taking this exponent right here and sharing that to the a and the 3, but we can't do that because when it's squared, what does that mean, you guys? That means we have two of those bad boys, right? I've got Ichi and I have Ni. Okay, we've got two of them, which means I have to distribute. So I have to give that -a to both of those guys, which would give me a squared plus 3a, because a lot of negatives we're dealing with. That guy's donezo. And then I share that to both of those guys, right? Which would give me another plus 3a and a plus 9. And then remember, I would just simplify here. And this problem does not ask to factor. It just asks us to simplify or give us the value of the expression. And that's done. And since it started with variables and it has a variable over here, that means my final answer is going to have variables in it. Okay, make sure you hit pause, look at that if you need some extra help. But we're going to get going here, and we get to do some word problems, all right, and some real life application problems, which actually is really helpful. I know sometimes I'll go shopping and I'll go to some Bed Bath and Beyond to get some new shampoo, or go get the wife a new kitchen utensil or whatnot, or a cool new air fryer so I can make my own French fries. And sometimes I'll have like some money off, and sometimes I'll have a discount, and I'll go to the register and I'll be like, hey, does it matter which one we use first? And they're like, it doesn't matter which one we use first. But guess what? Sometimes it does. And we're going to talk about that right now. Like what we all love pizza, right? Give me some pepperoni pizza with some ground beef, or maybe some hot giardiniera with some spinach and onions, right? We're going to do this problem here, and we're going to make it more relative. So we're going to say, like, when I order my large pizza, then my large pizza costs, I'm going to say it costs, let's see here. Ooh, I got to get my pen going. Let's see. Oh, P. Whoops, we don't want to print that bad boy, right, class? Okay, so here we go. Let's use this pen. Okay, so we're going to say that my large pizza, when I order it with all my good fixings, it comes out to $20. All right, and then it says here that says, how much would you pay for a large pizza if the cashier applies the coupon first? Okay, we're going to do this. We're going to actually break this in two. What happens if I do the coupon first? What happens if I take that discount first, right? Some of these stores are going to say it doesn't matter, but maybe it does. Right, let's see if it does. All right, so first what I'm going to do is I'm going to create some expressions, okay, some equations to work with. And I have a coupon. So I'm going to call my coupon function C of X. Okay, and it says the coupon is good for $5 off a large pizza. So I'm going to call that X minus 5. Now, do we know the price of the pizza in my specific example? Yes, we're going to say it's $20. Okay, but first I'm just going to set it up because, hey, we don't know what you guys like on your pizza, right? All right, and then what else do we have here? We have a discount. Okay, so we're going to say the discount on this side, we'll put it over here, is 10%. Well, how would I represent that? Well, that would be the price of the pizza minus 10% of the pizza. So if I did my math correctly, those are like terms, which would give me 0.90x. So that's how much I would pay for that pizza. I pay 90% of the price. Okay. In my specific example, if I use the coupon, it'd be 20 minus 5, that'd be $15 pizza, right? If I just got the 10%, that would be $20. 90% of $20 is $18. Okay, so definitely I would want the coupon here. But you know what's awesome about this store is I can use both. But the question is, which one do we want to do first? Okay, so we're going to check it out here. All right, for this example right here, I'm going to set up a composition of two functions. Why? Because I want two things, right? I want both. I want that discount, right, and the coupon, right? So let's say this time we're going to go C composite D of X. And then over here, we're going to do C. I'm going to do D composite C of X. All right, so which one of these would mean I'm taking the coupon first? Which one of these would mean I'm taking the coupon first? Which one would mean I'm using the discount first? Well, let's see. You know what? The answer to that is I just have to write what it means. This means C of D of X. That would mean I'm doing the discount first. Why? Because please excuse my dear Aunt Sally tells me whatever I do in the parentheses, I do first. Okay, this one over here would be D of C of X. So guess what? That means I'm going to do that first, which means I would be using the coupon first. All right, so here we go. This is C. What's D of X? D of X was 0.90x, right? And then I'm going to do the coupon, and the coupon's right there. It means you're going to put whatever's in the parentheses in for X. So it's going to be, you're going to take 90%, and then you're going to subtract 5. Okay, and I did this math earlier, and if I do the discount first and then the coupon, the price of my pizza. So if I did C of D of 20, okay, that would be 0.9020 minus 5. That would be $12.50. It's a pretty good price pizza. I don't know about you guys. That's not too bad. I might get some pizza tonight. All right, this one here would be your D, and then we're going to do this guy first, which would be X minus 5. Okay, and then now we're going to do the discount, which is 90% of X. So that means wherever I see an X, I'm going to put in this X minus, right? There we go. There we go. And then if I distribute, I get 0.90x, and that'd be minus 4.5. Okay, and if I did the math there, I would get, should use my notation, right? But if I do D composite C and then put 20 in there, which would be 0.90 times 20 minus 4.5, $4.50, I get an answer of $13. Now, I don't know about you guys, but I would take 50 cents any day. I could buy some gumballs, right? So it says, how much would you pay for a large pizza if the cashier applies the coupon first? If we apply the coupon first, which is this, that means I would pay this much. Okay, and then depending on the dollar amount, right? You're noticing here for this particular problem, it's you get the much better deal in this situation right here if the discount is applied first before the coupon. Okay, so this company here, they're ripping me off, right? And I should tell that manager, hey, please do the discount first and then the coupon second. All right, and then I got 50 more cents, right? I got 50 more cents in that situation. All right, let's go ahead to our next one. Okay, same type of example here. Okay, and this example right here is asking let's say we are at a store, and when you're working, some of you guys might be working jobs, and sometimes there's like 15% off. But hey, if I'm working there, I get even some more off, right? I get 20 more percent off than that. All right. And the question is, if you're an employee, what would you want first? Which discount would you want them to take first in your situation? So here we go. We're going to first define some things, and the store is offering a discount. So I'm going to say store. S of X equals 15% off. So that would be X minus 0.15 of X, because that's 15%. Those are like terms, so that means I can add them together. Remember, this is like a 1, so 1 minus 0.15, it's like $1 minus 15 cents, it's 85 cents. Okay, and then over here, let's say E, we'll call this E of X. I think it's helpful to use variables here that could help you to remember what it's about. E would be the employee discount, right? And that would be X minus 0.20x, which would be 0.80x. Okay? All right, so we have that right there. Now we're going to see these scenarios. Okay, let's do A. A says 15% discount and then the 20. Okay, 15% and then. So I have to do the 15% first. So this would be a case of E composite S. Okay, whichever one I want to have to first has to come second here, because that'd be E of S of X, right? That means you're going to do the store discount first, which would be the 15%. So if I do the math here, and I don't know the price of anything here, but you know what? It's going to be interesting what happens. Whoops, that's 0.85x. Sorry about that, you guys. And then if I do E, it means I'm going to plug a 0.85 in for X over here, and that would be 0.80 times 0.85x. And if I do that math, I get 0.68x. So I'm going to have to pay 68% of the original price. All right, let's go ahead and do B here. Okay, this means I want the employee discount first. If I want the employee discount first, it has to come second in the equation. Okay, because if it comes second, that means it's going to be in my innermost parentheses. And please excuse it, my dear NCL, it means I got to do that first. Okay, case? Okay, so E of X is 0.80. So now I got 0.80x. And then that means I plug that into the S. So I'm going to plug that into that X. And I get 0.85 times 0.80x. Oh my gosh, that seems like the same exact numbers as the one we just did. Oh snap, I pay 68% there. Trick question. If I'm an employee there and they're both discounted, and it's not like you're taking $5 off like that pizza problem, hey, it's going to end up being all the same in the end. How about that? I don't know about you, but that is pretty darn interesting. Okay, last one of the day. $1,500 computer. Which one is going to give me the better deal, class? All right, and this one asked me to do a lot of things. It's asking us really to do the same things that I was just asking you guys to do with those previous problems. Okay? All right, so here we go. It says write a function to represent the price after the discount. Okay, so they want us to call this f of x. Okay, and I'm going to call that discount. I'm going to call that d of x. I'm going to change it. And as long as I say they're equal to each other, I'm good to go. Okay, because I think if I do that, then it's going to make it easier to understand what I'm doing as I'm setting up a composition of two functions. Okay, so we have d of x equals, so the discount is 5% discount, so that would be x minus, now 5% as a number would be 0.05 of x, which means that is equal to 0.95x. Okay, and then we got b, kind of setting it up the way we did these other ones. They want us to call this g of x, but it's a rebate, so I'm going to call it r of x. And the rebate, I get $1,500. At first I said it was $1,500 computer, but this means I get $1,500 off of the computer. So that'd be x minus, you just get 1,500 bones off of that. Sweetie sweets. Okay. And then it's saying, okay, suppose the, oh, snap. Mr. T, read the problem, yo. It is a $1,500 computer. I get 200 bones off. Man, $1,500 would be a free computer. What? All right. So it's a $1,500 computer. They're telling me how much the computer costs. So that's how much X is. Use a composite to find the price of the computer if the discount is applied before the rate. Discount before. Okay, so that means the discount has to come second. Okay, once again, that's why I used R and D. So that would mean R of D of X. right, I'm going to change one thing because they actually gave me the price of the computer, right? And that means I'm going to put a 1500 in here for X. Okay, and you're allowed to do that. Okay, now remember, it's like the first problems we did today. So I need to know what D of 1500 it is. Remember, this side work over here can help out. Well, what would that be? Well, it's a discount 1500 because we're going to take the discount first, right? That's what it said to do. To find if the discount is applied before the rebate. So we're going to find the discount, and the discount is, okay, so the discount equation is this guy right here. So we're going to do that first. So that means it's going to be 0.95 of 1500. And I did this math earlier. Let's see what I got as an answer in my little trusted notes. And if I did that, it's 1425. So far, ooh, I like it. Price is getting cheaper. Okay, so now it's R of 1425. Okay, now I'm going to use the R equation, and the R equation is over here, and it says I have a rebate where I am going to take $200 off. So if I use this example over here, I pay $12.25 for that sweet new computer to watch my flipping classroom Mr. Tanaka notes at home. Okay, but which deal would be better? All right, so we're going to test it against this guy here, and this guy here says that we want to do the rebate first. So that means it would be the discount composite rebate. Remember, rebate first means rebate comes second. So that'd be D of R of, whoops, I'm gonna put 1500 in here, right? Because they gave it to me of 1500. So since they gave me a number, I want to come over here. I want to do some side work, and I'm going to do rebate. Rebate's this guy over here. So my rebate means I'm going to take 1500, put it in for X. I'm going to subtract that rebate. So it's 1300. So right now I'm paying 1300 for this bad boy, but guess what? I did not take the discount yet. So now I'm going to come over here and I'm going to take the discount. The discount says 0.95 of X. So 0.95 times 1300. Okay, I did this math earlier and I got 1235. Oh, snap. I am taking this deal over here because that means I can go to Mickey D's and get me the 2 cheeseburger meal and even a ice cream cone after that, and maybe even upgrade my fries to some supersized fries, right? $10. I don't know about you, but I'll take $10 when I can. So when I went to buy this at Staples or whatnot, or Best Buy, and they try to tell me it doesn't matter if there's money off, a rebate, or the discount, which one do you want first? Well, I want the one that's going to make me the most money. So next time I go to Best Buy to go buy myself a computer, I am bringing the calculadoras. That's it for today, you guys. Hopefully it's going okay. We only have I think a couple more sections here in 6-6. Aloha's coming for class if you need help. Aloha.